Welcome to the second video in part 2. In this one, we're going to be looking at straight lines where we're given 1 point and then some other information. Just think for a second, if we're only given 1 point and nothing else, we wouldn't be able to define a unique line. Okay, so let's look at our first of 2 examples. Determine the equation of the line parallel to 4x minus 2y equals 6 and passing through 4, 1. Now I've already got the sketch above me, which you wouldn't necessarily be given. So we're seeing parallel lines, and we should be thinking back towards, well, if we've got a line and a parallel line, well, the gradients are the same. So if we can work out this gradient, we know the second gradient will be the same. So in other words, this line over here is going to go through that point and be parallel. I don't know exactly where it's going to hit, so I'm going to go there and then just stop, because I don't want to assume that it's going through -7 or -6. My drawing's definitely not that great. So we need to work out the gradient of our original line. So this line over here, we need to work out the gradient. Well, if we could put it in standard form, we could just read that off, because we only know 1 point. So let's rearrange that equation, or manipulate it. So we got minus 2y equals minus 4x plus 6. Okay, and then divide both sides by -2, y equals 2x minus 3. Seems to fit the graph well as well. Just always check yourself. Well, this is a positive gradient, is a positive gradient. Looks like it's steeper than 1, because this is -3, and that's about 1.5. Yes, that seems to match. Just keep checking yourself as you go. It's definitely a useful skill to do. Okay, which means that in our other graph here, so I'm just thinking, how do we describe, or maybe just going to put a little line there to go, well, in the graph we're interested, y equals mx plus c. We know that m is 2 because the lines are parallel, the gradients are the same. Now, we could work with our gradient and go from this point. So remember before, what we did was we said, well, we could use our gradient to go, well, we're going left by 4, and that means we must be going down by 8. So just think of our gradient here is 2. So in this case, if we've got a rise of 8 and a run of 4, that will give us our gradient of 2. So we can see that this must be -7 down here. Okay, so that's the one option. Second option is just substitute the point you were given. So in this case, we could just substitute and say, well, 4, 1 is here. So x is 4 and y is 1. So equals 2 plus c, and 1 minus 8 gives us the -7. You see, you're kind of doing the same thing anyway, just you're doing it algebraically. So I keep saying this because I think it's a good push, is just keep building that conceptual with that algebra. The two work very much hand in hand. So -7 equals c, y equals 2x minus 7. Okay, so there we go. We've belabored and really thought through it, but that's the point of these as well, is we think through it in depth, and then you're going to do it. You could do 100 of these and do them quite quickly, and that's great, but just keep thinking through it. It's developing your mathematics. Okay, let's look at a second and final example for this video. Find the equation, or determine the equation of the line perpendicular to 2y plus 5x equals 10, passing through -5, 3. Again, I've got a little sketch here. You may not have the sketch, but just pause, jot it down, and it's nice to have that visual that's working. I mean, you saw that it helped us do this with gradient. Without the visual, if I block the visual, then it would be more difficult. Okay, so enough scrolling around. Here we are. Find the equation perpendicular. So this line here is going to be perpendicular, so it's going to go through here at 90 degrees. So it's going to go like that, and wherever it hits here, it's going to be at 90 degrees. I don't know exactly where it's going to hit, so I don't want to kind of draw this through there, assuming but it might be somewhere around there. But I can't assume. I definitely haven't drawn this accurately enough, and it could have been 4,9. Okay, so if it's perpendicular, let's take our original equation here, put it in standard form, because then we can work with the gradients. Okay, so in this case, we've got 2y equals minus 5x plus 10, y equals minus 5 over 2x plus 5, I think. Okay, 5, y-intercept 5, things look like they're matching up, negative gradient. Okay, so that's our first line. Now, this second line that we're actually trying to find the equation of, we know that when we multiply the two gradients, we must get negative 1. But we also know a little shortcut, and that is this second gradient must just be the negative reciprocal. Remember, you just kind of flip it around and change the sign. So we don't have to actually go through this algebra to find it. Minus 5 over 2, 2 over 5. And now we need to find our y-intercept. I think for this one with these fractions, maybe it's not going to work too badly, but let's just substitute a point in and see. So 3 minus 5, or minus 5, 3. So minus 5 is the x value, 3 is the y value. And so we've substituted that in so we can find out our y-intercept. Well, this is minus 2, so c equals 5. Okay, so our final equation is y equals 2 over 5x plus 5. Out of interest, let's just do it the other way to say, well, if we're going along here, we're running by 5. So therefore, how much do we need to rise by so that our gradient is 2 over 5? Well, that must be 2, in which case from 3 up by 2 gives you 5. Might have been a quicker way to find our y-intercept. So play with both. If you have a bit of a chance, try it by drawing the picture and trying to work with gradients to find your y-intercept. It's definitely a good skill. Okay, that wraps us up for part 2. I think it's time for you to enjoy exercise 2. And there is exercise 2. I will move somewhere out the way. There we go. Determine the midpoint of AB. Just there. So yeah, have a pause if you need to, just to get that exercise done, and enjoy. I'll see you in the next part.